Hello everyone. Today we're going to talk about the second type of lenses. The second type are called a concave lens. The concave lenses are thinner at the center than at the edges. I want to show you this figure here. As you see this figure, it's thinner in the middle than at the edges. It's not like the convex lens. It's the opposite. Also, concave lens, they known as a diverging lens because that's why they are used to spread light. So, which means if there is a ray of light, this ray of light parallel to the principal axis, they will not meet on the other side. When they refract, they will not meet, they will go away from each other. The same thing for concave lens. We want to learn the rules for the concave lens and for the rules of a ray of light. To understand first these rules, bring a pencil, paper and ruler to start drawing together these rules and to understand these rules. The first thing you have to draw at the middle here is the concave lens. At the center of concave lens you have to determine this is the optical center. So the same as here, it's the thinner, but here at the center also it has O, which means what? The optical center. Draw the principal axis. This principal axis you have to mark on like a F1, which is the focal point. F1, this is the from O, which is the optical center, to the this one here. Maybe it's not clear for you. O, I'll make it clear for you. This one here. This is O, okay? Please, maybe it's not clear, but make it as O. The distance between the optical center and F1 is it should be, this is the focal length. For example, I put it here, for example, 2 centimeters. The distance between F1 and 2F1, which is also 2 centimeters, because the double side is double length. On the other side you have F2, the distance between optical distance and optical center, and F2 is 2 centimeters, and between the F2 and 2F2 it should be also what? 2 centimeters. So these are the basic thing to start drawing these rules. Let's start with these rules. At the middle also I want to remind you, you have to put like line at the center of the lens. Okay, what are the rules that we are going to learn to know what are the properties of the image that is formed from the concave lens. Let's start with rule number 1. Rule number 1 here: a ray of light which is parallel to the principal axis after refraction appears to be coming from the focus or the focal point. Let's do it together and draw it with me now. So this is the ray of light. This one is parallel to the principal. To stop here. How it will refract, look at it. This is the direction. How it will refract. It will refract from this point like this. Okay, but look at the direction. But it appears what? It appears like, I'll use different color to show you how it appears. It appears like it's passing through the from this point it appears like it's passing through the focal point. Okay, so this one use like dots here to show you this is not the one that is refracted exactly. like dots like this. Okay, so this is rule number 1. Let's go back to rule number 1. A ray of light which is parallel to the principal axis after refraction appears to be coming from the focal. Here, as you see how it appears here, it refracted to that way, but if you extend it, it appears like it's coming from the focal point. Okay, that our focus point. Here, rule number 2. Let's talk about, or before we start talking about rule number 2, we have mentioned concave lenses. They are diverging lens. Why they are diverging lens? Because if you look at this figure here, all parallel light, when they these lights, when they pass through the lens, they will be away from each other. When they refract, they will not meet. Okay, that's why it's called what? Diverging lens, and that's why it's used to spread the light. Let's move now to talk about rule number 2. Rule number 2, a ray of light going toward the optical center of a concave lens goes straight through without being deviated. The same thing as we mentioned for the convex lens. Let's do it together. This one here, you have a ray of light, yellow, passes through this optical center here. It will not what? It will not refract. It will not bend. Look at it. So this is the direction. It will continue passing without deviation. For rule number 3 now, let's talk about rule number 3. Rule number 3, a ray of light going toward the focus after refraction becomes parallel to principal axis. Let's do it together. So again, a ray of light for rule number 3 going towards the focus after refraction becomes parallel to the principal axis. Let's do it together. This is the ray of light. Look at it here. But I want to show you something here. Stop at this point at the center. Look at the direction. This one, I'll take what? I'll take the extension of it. Okay, like it appears, like it comes from the, it passes through the other side focal point. Look at it. I'll use different colors here. I'm sorry, I have to put it from the same point. Use the ruler to do it. Look at it. How this one, how it will refract. This is the extension for the light. Okay, how it will refract. Look at it. This one, it will refract what? Parallel to the principal axis. Okay, pay attention to this one. This one, to make it clear, use dots because this one is extension. Okay, يعني it appears like it. Use the ruler. يعني it should be what? The same line. So maybe this one I make that clear for you. Look at it. Maybe this one more clear. This part here represent what? The light ray. Okay, it passed through the focal from the other side. How it will refract? It will refract parallel to what? To the principal axis. So these through rules for the concave lens. For the concave lens, to understand how to draw the image, we said the factors that affect the property of the image, it depends on the type of the lens or the shape of the lens and the position of the object from the lens, or how away from the. For concave lens, it doesn't matter where you put the object. Wherever you put the object, it will give the same property. Okay, the same thing for concave lens. Only 2 rays are enough to draw the image. Okay, to draw the image, only 2 rays are enough. Now we will start drawing the image for concave lens. Let's do it together and determine which rays we're going to use, and prepare your ruler, your paper to draw with me. Okay? Now the rays that I'm going to use in my drawing here, a ray of light passes through the optical center, the other one parallel to the principal. As we mentioned, it doesn't matter where you put the object, because for the concave lenses it doesn't matter. Anywhere they will give the same property for the image. Now this is the object. I'll put it, for example, here at this point. This is the object. The arrow here at the top of the arrow represents the top of the object. Let's start with the first ray. The first ray here, I'll use the yellow color, which is parallel to the principal axis. From the top of the object, you take it like this, you stop at this point, at the center. Okay? Now we'll start to make how it will change the direction, how it will refract. This one, it refract how? Again, let's go back to the rules. The one that is parallel to the principal axis after refraction appears to be coming from the focus. So let's do it together here. Sorry. This one here appears. This one to refract this way, away like this. But I'll use other color to show you how it appears. It appears, this is the extension here. Okay, so from this point it appears, sorry, from the same point it should, it appears like it comes from what? From the passes through the focal point. Okay, so it's, this one is the extension, it's not the light itself. Okay, so the second one, the second light ray, I'll use again yellow color. Light passes through the optical center from the top here. Look at it. From the optical center, it will not be deviated, it will not change the direction, it will continue moving the same the same line. It will not be refract, right? So as you see here, these two rays here, like they diverge, right? That's why it's diverging lens. The rays, they don't meet when they refract. Where did they meet here? If you go extend this one, the second ray that I put here, if you extend it, they meet at this point. So the top of this point here, it's what? Because the top of it is what? Is the top of the object, the image of the object. And as you see here, let's talk about the properties. Look at it here from the extension, right? So this one, the property, the first property, is it real or virtual image? So because from the extended rays, so here refracted rays, so here it's what? Virtual image. This is the first one. Look at the length. Which one is smaller? For sure the image is smaller than the object, so it will make what? Smaller image. The third thing is what? Look at it, it's right side up. So wherever you put the object for concave lens, it will give the same properties. Let's write these properties. The first one, virtual, it's not real. The second one, it's what? It's right side up. The third one, it's smaller. So these are the properties for the image that is formed from the concave lens. Now I want you to show like small video and write notes to understand more about the use of the concave lens. Listen carefully.
Shows a diverging lens. This diagram shows a diverging lens. On this lens, the center is thinner than the edges. It is concave on both sides. The diagram shows what happens to light as it passes through a diverging lens. Parallel light rays that travel toward the lens are refracted as they pass through it. Because of the shape of a diverging lens, the light rays are bent outward and spread out. You may have seen diverging lenses in eyeglasses that help with nearsightedness. People with nearsightedness have difficulty seeing things at a distance because their eye focuses images in front of the retina instead of on it. The lenses in their glasses help focus the image on the retina.
Okay, so now because here we're talking about the property of this image, look at it. Look where is the location of the image. It's in front of the object, yani it forms. Okay, look at it here, where it's the location, how it is smaller, virtual, right side up. Okay, I want you to draw it, then send me your drawing. And I want you to solve equation 14, page 111. So these are the homework for you for today. Thank you for listening.